Okay, so we're starting here really right at the surface level. The main ideas in personal finance revolve around understanding interest rates and the time value of money, how money tends to grow in value over time when it's invested, or how debt tends to grow over time when you owe it. And so what we're going to be doing today is learning the math behind this. So we can start off with this relatively simple question, a question I suspect a lot of you will understand automatically. But let's say I have $100 and invest it at a nice 10% interest rate. How much will I have in 2 years? And this is a mistake that I see frequently from students, and it's one that I would hope I'd correct very early on in a personal finance course. The tendency here is to think, well, 10% of $100 is $10. So if you invest for 2 years, you'll gain $10 after year one, and you'll gain another $10 after year two. And that will leave you with $120. Of course, this is incorrect, right? The failure here is not applying compounding interest correctly. When money grows over time, it doesn't grow linearly. It doesn't grow in a straight line over time at a constant rate. Instead, the interest grows on top of itself. This is a very important thing to recognize in personal finance. So in the first year, when your money grows from $100 to $110, now you have $110 invested. So when you take 10% of $110, you're going to see that you grow by more than $10, okay? So let's apply the math. Let's learn the terms that we need, and let's apply the math. We're going to be using, of course, interest rates. And it's kind of a silly term to define because I'm guessing that all of you really already know what an interest rate is. But it's a numerical value that reflects the growth of money, whether we think about that in terms of money you owe, like debt, or whether we think about it in terms of money that you have. Notice just how important this is in personal finance, because when it comes to paying off your student loans or taking out a mortgage or saving for retirement, interest rates really are what govern your ability to pay off things quickly when it's debt, or to save for retirement quickly when we're thinking about saving. So this is obviously a really important point. A lot of what we're going to be talking about here is trying to figure out ways to maximize the interest rate that you earn when you're saving money and minimize the interest rate that you pay when you're borrowing money. Mathematically, some other ideas that we need here. We're going to use the idea of future value. A lot of these calculations should be things that many of you have seen before. And the future value is as you might assume, the dollar amount at a future date. The dollar value at a future date. And a lot of times in our calculations, the future value is the unknown. So if I say to you, I've got $80,000 in stocks, I might try to figure out how much would that be worth at age 60 if I get typical stock market returns. Well, I'd be solving for a future value, right? I'd be trying to figure out how much I would have in the future, which is very useful. And then the present value is the dollar amount today. So if I said I've got $80,000 and I'm trying to figure out what I'll have when I turn age 60, that $80,000 is the present value, okay? But just as we can solve for future value, there are also times where solving for present value is useful. So I might think to myself, I need $1.5 million to retire. How much do I need to save today to reach that goal when I'm 60? In that case, I know the future amount. I need $1.5 million. And the uncertainty is, how much do I need to save today? So these three terms here are going to be useful. And then the last thing that you're going to see in our calculations is N, which is just going to be the number of years between the present value and the future value, okay? And to be clear, these are not terms I'm going to ask you to define on a quiz or an exam. I'm not going to say, what is an interest rate? What a worthless question for me to ask, right? Instead, we're just trying to get the variables that we need to do some calculations. Okay? So let's get back to our original question here. And we'll see if we can derive an equation that will be really useful for us from this one question here. Trying to figure out how much I would have in 2 years. And without using a formal equation here, let's just think about the calculation, how we can actually get at answering this question. Maybe the easiest way to do this, if you're trying to just intuit how it works, is to think about where you will be 1 year from now. All right, the question is saying, if I save this for 2 years, well, let's sort of pick a stopping point. Let's say how much will we have after 1 year, okay? After 1 year, we can solve for the future value by taking the $100 and saying, this is how much we will have, okay? We will definitely have $100. That's how much we save. We might call that the principal, which is how much you're starting with. And then we'll just need to figure out how much interest we're going to earn. Okay, and this is obviously an easy question, right? 1 year, 10% interest, you save $100. Of course, you're going to end up with $110. So let's make sure that our math matches up with the answer that we know should be found. So that's how much our principal is. This is how much we're going to start with. We know we're going to maintain that $100. We need to figure out how much is going to be added to that. So we need to figure out how much interest we're going to earn. So in addition to that $100, we're also going to earn 10% interest, right? Or 0.1. Remember that 0.1 is the same as 10%. Make sure we remember that notation. And this 100 times 0.1, which is $10, is the interest earned, right? It's no longer an interest rate that we're solving for now. We're turning that into a dollar amount. And so, if we solve for this, what we will get is $110. Okay. Using this as a more formally, thinking about this, moving away from these specific values and thinking about how we might use this to solve for any value. For 1 year, the future value could be defined as the present value times 1 plus the interest rate there. Okay. That's what you'll find here. Notice there's $100 is the present value. I can pull that out, and basically what you're solving for here is, if I pull out this $100, okay, we can use this to be 100 times 1, and this equation, or this product here would be 100 times I. And so we can take this calculation and then use this generic formula to solve for it, okay? If you've done this sort of thing before, you can see this is starting to look like an equation that we're used to seeing in finance, but if I haven't told you before, there is no prerequisite for this class. So students are coming to this with a very different level of ability. Quite a few of you, I'm sure, have never actually seen this formula before. All right, so that works for 1 year, but the question, of course, asks for 2 years, okay? And again, the mistake that people will make is to think, well, it'll just grow by $10 again. If you think that, you're forgetting compound interest. And man, compound interest is just such an important concept. When you save money at a given interest rate, your money will grow at an increasingly fast rate. All right? It will grow at an increasingly fast rate. If you wanted to graph it over time, money saved grows like that. It compounds, okay? So I think it's useful to see this with dollars one time so you understand compound interest. Here's what's going to happen now. When you start year 2, you are now saving $110. The actual principal will change. And so now your interest is not built on $100. Your interest is now built on $110. Okay? So the future value mathematically is going to come out to this kind of clunky equation here. Okay, this is our principal. That's what we just solved for right here. Okay, I'm sorry, right here. So this is our new principal, right? We started out with $100. That was our principal when we were solving for year 1. But after year 1, we've got $110. And that is that $110 that we generated here. Okay, and we're going to add that to the interest that's earned. And again, this is clunky. This is not a formula you're really going to have to use again, to be honest. but this is what you get. Okay, it's a real clunky equation. If you solve for all of that, what you're going to get is $121, which is 10% growth from the $110 that we started the year with. Okay, solve for that. You know, anytime you're doing these videos, pause it, rewind. Make sure you understand the intuition about what we're doing here. Okay, this here is the principal. This term right here is the principal. That's $110. Okay, this here is the interest earned. And the reason we set it up this way is notice that we have some common terms here. 1 plus 0.1 is a common term. 100 is a common term. And so what we're going to be able to do is simplify these equations down to a formula. Okay? And what you will find is you can derive from this. All right? This is what we got. Okay? If we just take what we have here and replace the specific values with the terms, this is what we have. The future value is the present value times 1 plus I plus the present value times 1 plus I times I. Notice all of the common terms that we have here, right? This present value times 1 plus I is given to us in both of these terms here. And the only difference between these two terms is just the leftover I that we have here, okay? This is going to make this formula pretty easy to deal with, all right? I'm going to kind of leave that there so that we have it and just see where this equation that we're going to use so many times comes from, okay? So in this equation right here, what I want to do is I want to factor out the present value times 1 plus I. Okay, hopefully you remember doing this from math courses, right? You can take out the term that's common here, right? And then you can figure out a way to express this information in a more condensed and useful way, okay? So if we take this right here, the present value times 1 plus I, if we factor that out, what you should recognize is to get this term, all we got to do is multiply that times 1, right? These two terms are exactly the same. So if I take this and multiply times 1, I get that, okay? And then, for this term over here, what do I need to do? If I want to take this and turn it into this, what difference is there between these two terms? All I have to do is multiply it times I, okay? This times this is just I, all right? So what I've solved for here is after 2 years of investing, I can use this formula regardless of what the present value is and regardless of what the interest rate is. It is now a generalizable term, okay? And I could rewrite this as 1 plus I squared, right? The present value times 1 plus I squared is equal to the future value. Now we're looking closer to a formula that I hope many of you have seen. If you haven't seen it before, I'm always really happy that I get a chance to teach this because for those of you in the class that have used this, you know how useful it is, right? For those of you who've never used this before, I'm getting the chance to teach you something that is very useful, something that you might use a lot in your life. And frankly, as a professor, it's not always something that happens very often. We don't often get the chance to teach you something that you'll use a lot in your life, right? A lot of times teaching as a professor is just about helping you explore ideas, helping you find what you're interested in, challenging you, you know? But in this case, I'm giving you something that you'll probably use a lot. So it's very applicable to real life. So this works for 2 years, all right? For 2 years of investing, that formula would work. For 3 years of investing, that would be your formula. Future value equals the present value, 1 plus I to the cube. We could go through it and I could prove to you that that's the case, but it's probably not worth our time because all you're really going to need to know from today's lesson is our big formula here. Here's the formula that is applicable to any annualized compounding interest, okay? This formula right here we're going to use a lot. We'll modify it a little bit, but this is our basic formula that we're going to use to deal with the time value of money. The future value is equal to the present value times 1 plus I raised to the n. Present value is the amount you start with, I is the interest rate, and n is the number of years that you're investing. Okay? So write that formula down. And this will be just for annually compounding interest. I can imagine that a few of you in there that have taken personal finance are screaming at the screen right now saying that this formula doesn't always work. I know. This doesn't always work, right? This only is true for annually compounding interest. It's going to take a little second for us to understand what annually compounding interest is and how it compares to other types of compounding interest. We're just not quite there yet, okay? So, we've got future value, we've got present value, interest rates, and the number of years in our term here, and we're going to use this formula so often in this class.